Today we're going to learn the final method for solving systems of equations, and that method is called elimination. We use elimination when the coefficients for the x values or for the y values in both of the equations create a zero pair. So in this method, we can add or subtract the two equations together, and that will eliminate one of your variables so that you are solving for just one at a time. So let's look at an example. In this example, I have negative 5x minus 6y equals 8, and I have 5x plus 2y equals 4. I notice that in my first equation, my x value has a coefficient of negative 5, and in my second equation, my x value has a coefficient of positive 5. I know that because these are opposites, I can add them together, and that would create a zero pair. So, to use the elimination method, once I have found a zero pair, I'm going to take the two equations and I'm going to add both equations to each other. So both equations completely get added. I'll add negative 5x plus positive 5x, and that gives me 0x, which means they cancel. We need to be careful here because this is a negative 6y. So I'm adding negative 6y plus positive 2y, and negative 6y plus positive 2y is negative 4y. And then that equals 8 plus 4, which is 12. Now I have an equation that, and all I need to solve is for y. So to get y by itself, I would divide by negative 4 on both sides. These would cancel and leave me with y equals positive 12 divided by negative 4 is negative 3. Now, because this is a system of equations, I still need to find the value of x because the solution to a system of equations has to be written as an ordered pair. So I'll go back into one of my equations, and it doesn't matter which one. So if I choose my first equation says negative 5x minus 6y equals 8. I'm going to plug in negative 3 for y. So this is negative 5x minus 6 times y, but I'm going to use negative 3 for y, equals 8. I've got to simplify, so negative 5x, then negative 6 times negative 3 is positive 18, so I'll write plus 18 equals 8. To get x by itself, I'm going to subtract 18 from both sides. These are going to cancel and leave me with negative 5x equals 8 minus 18 is negative 10. Then, to get x by itself, I'm going to divide by negative 5 on both sides. Those will cancel, and that leaves me with x equals negative 10 divided by negative 5 is positive 2. So the solution to the system of equations is where y is equal to negative 3 and x is equal to 2. So as an ordered pair, that solution is 2, negative 3. Let's look at example 2. In example 2, I look at my x values, and my first equation has a coefficient of 6, and my second equation has a coefficient of negative 3. Those don't create a zero pair, so I'll look at my y values. My y in my first equation has a coefficient of negative 4, and my y value in my second equation has a coefficient of positive 4. I know that negative 4 plus positive 4 will create 0, so those are a zero pair, which means I can take these two equations and I can add them together. So when I do that, I have 6x plus negative 3x. 6x plus negative 3x is positive 3x. Then I have negative 4y plus positive 4y. Well, that cancels out to make 0y, which is just 0. So now I have my equal sign. 14 plus 1 equals 15. Now all I have to do is solve for x by dividing by 3 on both sides. These 3's will cancel and leave me with x equals, and 15 divided by 3 is 5. So I know that x is equal to 5, and now I need to find my y value. So I'll plug it into one of my equations. So if I use my first equation, that one says 6x minus 4y equals 14. I'm going to plug in 5 for x, so 6 times x, or 6 times 5, minus 4y equals 14. 6 times 5 is 30, so 30 minus 4y equals 14. Now I need to get y by itself. So I need to get rid of my 30 first, and I'm going to subtract 30 from both sides, because 30 minus 30 will make 0. I'm left with not 4y on this side, but negative 4y equals, and 14 minus 30 gives me negative 16. Now I have one more step. I need to divide by negative 4 on both sides. Those will cancel and leave me with y equals, and negative 16 divided by negative 4 gives me positive 4. So now I know that my x value is 5 and my y value is 4. So the solution to this system of equations is 5, 4. In this equation, I notice that I have 4x and 5x. So 4 and 5 are not a zero pair. I also have 3y and 3y. Well, these are both positive. Technically, that's not a zero pair either, but I can make it a zero pair. Instead of adding my equations together, if I subtract these equations, because if they have the same coefficient, I'm just going to subtract. If I subtract 3y minus 3y, it's going to give me 0y. So they will cancel that way. Now, when you're subtracting, you have to be very careful because you have to remember that you are subtracting every term in every equation. So this is 4x minus 5x. And if I do 4x minus 5x, that's negative 1x, or just negative x. 3y minus 3y is going to cancel, so then I just have my equal sign. Then positive 2 minus negative 2. If I do positive 2 minus negative 2, I actually get positive 4. Now, x looks like it's close to being by itself, but it still technically has this negative 1 with it. So I am going to divide by negative 1 on both sides, and that will get x by itself. Positive 4 divided by negative 1 is negative 4. So my x value will be negative 4. Now I'm going to take that and plug it into one of my equations. So if I use my first equation, that says 4x plus 3y equals 2. Instead of x, I'm going to use negative 4. So this is 4 times negative 4 plus 3y equals 2. 4 times negative 4 is negative 16. This is negative 16 plus 3y equals 2. Now I need to get y by itself. So I need to get rid of my negative 16 first. So I will add 16 to both sides. Negative 16 plus positive 16 cancels. I'm left with positive 3y equals, and 2 plus 16 is 18. So now the last thing I need to do is divide by 3 on both sides. These are going to cancel and leave me with y equals 18 divided by 3 is 6. So y is equal to 6. In this case, x is negative 4, y is 6. So the solution to the system is negative 4, 6. And our last example for today, in this example, I have 5 as my coefficient for x in this equation, and negative 1 is the coefficient for x in my second equation. Those aren't going to make a zero pair, so I'll look at my y's. For this one, I have positive 6, and this one I also have positive 6. So because those technically don't make a zero pair, I can make them make a zero pair by subtracting this second equation from the first equation. Again, you have to be careful. If you're subtracting, you have to make sure that you subtract every term. So the first thing I'm going to subtract is 5x minus negative x. If I do 5x minus negative x, remember there's a 1 there, so it's actually 5x minus negative 1x, and that gives me positive 6x. 6y minus positive 6y gives me 0y, so those are going to cancel. So I bring down my equal sign. Then 50 minus 26 gives me 24. Now to get x by itself, I'm just going to divide by 6 on both sides. These are going to cancel and leave me with x equals, and 24 divided by 6 is 4. So my x value is 4, and now I need to find y. So I'll plug into one of my equations. If I use the first one, it's 5x plus 6y equals 50. So I'll plug in 4 for x. So this will be 5 times 4 plus 6y equals 50. 5 times 4 is 20. So I'll rewrite my equation. Now to get y by itself, I'm going to subtract 20 from both sides of my equation. These are going to cancel and leave me with 6y equals 50 minus 20 is 30. Then I will divide by 6 on both sides. Those will cancel and leave me with y equals, and 30 divided by 6 is 5. So for this system of equations, my x value is 4 and my y value is 5.